Okay, so this will be about surface area of 3D objects. So the shape on the left is where we'll start. And you can see that this is a square-based pyramid. It's a square. All sides on the bottom are equal in length. You can tell by the dashes. So we'll just start by going surface area equals area of base plus lateral area. The lateral area is all the other area above the base. Basically all the area not including the base, or bases if there's more than one. So lateral area. So when we look at the area of the base, we can see that it's 9 by 9. So it's a square. So it's 9 squared plus the lateral surface area. One of the faces is triangular, and we can see that all the other faces are also the same triangular shape. They are the same size because the base length is the same. So we have a base of 9 by a height of 14.4, and it's a triangle, so we're going to divide it by 2. But there happens to be 4 triangles. So one on the left, just over here, the right, the front, and the back. Okay, so there's 4 of those. So there's going to be 4 of base times height over 2. The base being 9, height being 14.4, all over 2. Okay, and then we'll just reduce this to make this a little easier. So divide by 2, so that's 2, and we're dividing by 2 on the bottom to give us 1. So reducing earlier. So that's going to give us 81 plus 2 times 9 times 14.4. That's a 4. And then from there, we'll just do some quick number crunching. So we've got the 14.4. I'll put the closer bracket there. Okay, so we got the 14.4. So that times 9 times 2, we get that plus the 81 original for the base. So we get to 340.2. So I just put that down here. That's meters squared. Moving on to the cone. So the cone will be the same kind of idea. It will be the surface area equals area plus, area of base plus lateral area. So we're going to go surface area equals, the area of the base is a circle. So we're going to go pi r squared plus the lateral surface area in this case is a curved portion. And you can see over here that is represented by pi rs. So we're going to go pi r s, and then we'll just sub in our values. Keep pi, and we're going to use that in the calculator, times the radius of 37 squared. We're given the radius here, so we can see 37 plus pi, radius again, and in this case, the slant height. So slant height is the outside height of this shape. We don't want the inside height. Inside height's for volume. So for surface area, we use the outside height. So that's the slant height. Times that by 54. And then we'll just go and do some number crunching again. Okay, so back to the calculator. I'll start with the right side of the numbers. So we're going to go second function pi times 37 times 54. And we'll leave that number in the calculator. And then we'll go and work with pi r squared. So 37 squared. Use the exponent button. And we'll multiply this by pi. So second function pi. You can see my pi is above here. It's in yellow or orange. So we take that and add it to the original number. So the original number being the lateral surface area. So we take the answer plus 6276.902122. And we get 10,577.7. We're going to round it to 10,577.7, or a whole number of 10,578, depending on what the question's asking for. So we'll just put one decimal place here. So we'll go 10,577.7. And that's inches squared. Okay, so you'll see down here that it's been around to the nearest whole number, and that's fine, just based on what the question's asking for. Moving on. Looking for a surface area of a regular hexagon. So a hexagonal prism is what the whole thing is. You know it's a prism if there are rectangular faces. So anytime you've got rectangles, you're dealing with a prism. And then we're going to go and calculate the surface area of this pentagonal pyramid. And you know it's pentagonal because there's 5 sides to the base. And it's a pyramid because it comes to the apex. And the idea here is to see which one has more material if you are going to stained glass them. Okay, so let's just go and start with the one on the left, hexagonal prism. So to actually figure out the surface area of that hexagonal shape, so the hexagon, we're going to put a dot right in the middle, and then we're just going to show that we can break it down. Oops, that's not very straight. Break it down to 6 triangles. So one there, there, and over. Okay, so 6 of them. And then each of those is going to have a base, and this time you can see that that base is going to be 20. Okay, so this base being 20, and the height you can see into the center dot is 17. Okay, so if you were to look at that, this would be 20, and the height there is 17. Okay, so we'll just take that into account. There will now be 6 triangles with a base of 20 and a height of 17. Over 2 because they're triangular. But don't forget that we have a front and a back. So we're going to multiply this by 2. So something nice happens. We can just divide the 2's up. Okay, so that'll give us our surface area for the regular hexagonal portions. So let's just go and do that. So we have 6 times 20 times 17. So we get 2040. And that's in centimeters squared. Now the area of the rectangles, you can see that there are also 6 of those. There's a 6-sided figure, so 6 rectangles. So we just find the area of one rectangle and times it by 6. So in this case, the rectangle is 20 by a height of 10. So base times height. So 20 times 10 times 6 of them. And then we go and crunch those numbers. So I think it's 1200. And again, centimeters squared. So then when we go down to the next part, we're going to find the area of the pentagonal pyramid. So we'll do something very similar. We'll put a dot in the middle, and we'll create 5 triangles. In this case, the base of each triangle will be 16, and the height of them, you have to look up here for that, is 11. Okay, so what we're dealing with, if we're looking at this inside shape, dot right in the middle, and just pick one of the triangles to draw. So there's one there. Okay, so that means this base here is the same as this base, 16, and then this little height up to the center is this number 11. Okay, so it's going to be 16 times 11 for one triangle, but there's 5 of them. So we'll just take 5 times base times height over 2. In this case, again, the base was 16, the height was 11 over 2. And that'll give us the surface area of the base. There's only one of them this time, so we don't need to double it. So 5 times 16 times 11 equals, and then divide that by 2. So we get to 440 centimeters for 40 centimeters squared. And then when we go and look at the area of the triangles, we can see that there's 5 triangles. Again, we have a base of 16, but this time the height's 24. Okay, so let's just go and do that. So 5 triangles. So 5 times the area of the base. So 16 times 24, all divided by 2 equals, and again, crunch those. So we can see that 5 by 16 by 24 gives us that value divided by 2 is 960. 960. Okay, and now we're going to look at the totals. So let's just do a quick calculation here. The total for the first one we looked at, we're just going to add 2040 plus 1200. Okay, so we'll just go and show that. So we'll go 2040 plus the 1200 equals 3240. So we'll go and write that over here. 3240, and that was centimeters squared. So the stained glass required for that shape is 3240. Let's check out the other one. So the total here, just add these two, so 440 plus 960. Again, just to show that, 440 plus 960, we get to 1400. So we just put that down here, so 1400. And that is, again, centimeters squared. Okay, so to go and just double check, it says which figure requires more stained glass? Well, then that will be the hexagonal prism. It obviously requires more. Moving to the next part. Rubik's Cube. Okay, so for this one, we're looking at the surface area of a Rubik's Cube. It's given, it's 54 square inches. And then we're just asked for the dimensions of each face. Okay, so let's just think about how do you find surface area of a cube? Well, surface area of a cube, if you think about it, is a 6-sided figure times the area of one face. So one side length could be S, the other one could be S. The other one could be S. So we just let it be the same variable because they're all squares and they'll have the same lengths. So then from here, we'll just take what we know. 54 square inches is what we're dealing with. So we put that right there. And we're just basically solving for the side lengths at this point. So we're going to take 54 divided by 6 and then square root that. So just to show all steps. To isolate for the S variable, we're going to use opposite operations until the variable is by itself. So in this case, we have 54 and 6 still equal to 6 times S squared. To get the 6 out of there, we want the S isolated. So we're going to divide the right side by 6. And the left side by 6. That will isolate this S. It'll still be squared, but there won't be any coefficients. So 6 divided by 6 is 1 over 1. And then the 54 over 6 is what we're left with. Okay. So then from there, we just go and write down what we have at this point. So we're just going to, I'll put it up here. We have 9 equals S squared. And now the opposite of squaring is square rooting. So again, we're going to do the opposite operation until our variable is all by itself. So S squared square rooted and 9 square rooted. Okay. So the square root of a square is just what the base was, in this case, the S variable, and the square root of 9 we know is 3. And we're dealing with the positive square root for this one. So we know that the dimensions will be 3 by 3 by 3. For each one of these lengths, but for the surface area, if we're just concerned with the base times the height, 3 by 3. Okay, so we just know the side lengths are S. Okay, so next one. We have two shapes here, and the scenario is we've got a person named Trish wrapping two gifts. Dimensions are shown. Which one needs more wrapping paper? So basically, we're looking at which one has the larger surface area. So if we're looking at the rectangular prism, again, we know it's a prism because there's rectangular shapes. We can see that there's a front base of 30, a width of 10, and a height of 20. Okay, so we'll just work with that. So we're going to double everything for this one. So it'll be a little more straightforward because there's two sides that are equal in each scenario. So for the surface area of this one, we're going to go surface area equals 2 times, let's do the front and the back together. So 30 times 20. So then when we go 30 times 20, we're going to add that. Let's do the sides. So the right side and the left side. You can see that there's two being the same shape. So we're going to go 10 times 20. And then from there, we're also going to add the third section, in this case, top and bottom. So the bottom you can see is 30 times 10, and there's a top with the same dimensions. So it's 2 times 30 times 10. Okay, and then we just go and crunch those numbers. See what we get. So we're going to go 30 times 20, and we're going to double that. So we get 1200. So that's on the bottom. I'll just keep this in the calculator so we can see it. And then the next one, we're going to go 20 times 10. Again, we're going to double that. And then we're going to take 30 times 10, and we're going to double that. So those are all our numbers. So 12, 4, and 6. 1200, 400, 600. So we'll just put those down here. 1200 plus 400 plus 600. And then we'll just total them up. Okay, so add them up. You get to 2200. And this is going to be in centimeters squared. So 2200 centimeters squared. And then the second part, we're going to look at the surface area of the cylinder. So the surface area of a cylinder, we need to think about what the equation is for this one, because it's a different shape and there's circles involved now on curved surfaces. So in this case, to find the surface area, we just add up all the shapes. There are two circles, so 2 pi r squared. Remember, pi r squared is the area of a circle. And then we're going to add the label, basically, or the lateral surface area. So to do that for this one, you're going to multiply 2 times pi times radius times height. Okay, so we'll just go 2 pi. Again, we use the pi button. Radius is going to be half of 15, so that's going to be 7.5. So just divide by 2 to get the radius. So 7.5. Keeping in mind we're squaring it. Then add 2 pi rh. So again, 2 pi, radius of 7.5, times the height, in this case, of 30. Okay, and then we'll just crunch those numbers and see what we get. So let's do the right side here. So we'll go just get our pi in there first. So pi times 2, and then we'll multiply that by 7.5, and then we'll multiply that by 30. So that's the right numbers. Keep that there so you can see them all. Now we'll do the left side. 7.5 squared times 2 pi. 7.5, use the exponent button, little hat, squared times 2 pi. Again, second function pi button. So the left side is these, all of that, plus 1413. Take as many decimal places as you can from the previous number. So we get that number there, which we'll write down. So 1,767. And if we were going to round that, it would just be 1767, and that's going to be centimeters squared. 1767, we'll just put down here. And centimeters squared. Okay, so if we were going to say which one needed more wrapping paper, you can see that that rectangular prism needs more. Okay, moving to the next part, kind of an extension from the previous question. So we're saying use the formula to calculate the surface area of the cylinder in question 4. Okay, so we have, we'll just show that there. So we've already done that, so there it is for that one. It's kind of a repeat. Moving on. Okay, for this one, we're looking at making enclosed tents with dimensions given. And the two sides in the bottom are rectangular. We're told that. And then the ends are triangular. So we're looking at how much fabric is needed to cover this thing out, basically to make it. So we're looking for surface area. And let's just notice one thing. The right rectangular face has a length of 5 and a height of 3.5. You can see that the bottom has the same dimensions. And the other rectangular face on the other side that you can't see has the same dimensions. So technically there's 3 rectangles with the same dimensions. And then there's a front and a back triangle. They're going to also have the same dimensions. So really, we're going to do 2 calculations, one for triangles, one for rectangles. Okay, so let's do that. So we'll go surface area equals the triangles. It's going to be 2. The base times height in this case, base is 3.5, height is 3 for the triangle, times 3 divided by 2. So 2 triangles with that base and height over 2, plus there's going to be 3 rectangles, 3 times base times height, rectangles that are 5 by 3.5. So we just go 5 by 3.5. Okay, noticing over here that 2 and 2 reduce to 1 and 1. So that just leaves 3.5 times 3 plus 3 times 5 times 3.5. Okay, so then we'll just crunch those and see what we get. Okay, so 3.5 times 3, so that will be the first set, so 10.5. And then we'll just take 3 times 5 times 3.5, and then we'll add those together. So that answer plus 10.5. So we get to 63. So in this case, just put 63 here. And what is this? Yards. Okay, so yards. So we're actually looking for square yards. This is area. Square yards. Okay, so when we're looking at this here, the next part's saying if canvas is 489 per meter squared, how much will the fabric cost to make the tent? Okay, so we just take that 63 that we know and we work with it. Okay, so we're going to use the conversion factor, if you can see on the right side here. We're moving from what we saw square yards to meters squared. So we need to convert and multiply, or work with, sorry, our number of $4.89. Okay, so to do that, I'll just move this out of the way and we'll finish this up real quick. We're going to recognize that sometimes our decimal places are a little different, a little more exact for one than the other, so just be aware of the differences. In this case, we take our previous number of 63 yards, which we had worked out up here. That's the canvas needed to cover or make the tent, multiplied by our conversion factor. So we multiply that to convert it to meters squared. So we get 52.668 meters squared, and then take into account the dollar amount. So 52.668 times 489 per meter squared, and that'll get you about $257.55. And that's the cost to make a tent or create a tent with that canvas covering an area of 63 square yards.